Okay, so yesterday, if you still have your sheet from yesterday, take that out. At the base lab. If you don't still have it, that's okay, because you're going to have a new sheet to record your data on today.
Why do we have to do that?
Okay, so we picked a few chemicals to use today. So we have vinegar that you guys said was a pH of 3. Using the pH paper, you found the pH because we had the color change chart to look at. Aspirin you said was a 4. There's some shampoo that 6th Hour had that Travis Huntington brought that was a 5. And some chai tea that Tiffany brought that's a pH of 6. I have distilled water that's at a 7. Baking soda dissolved in water was slightly basic, so was Lysol, Windex, Tide, and drain cleaner. I want you to write these down on the sheet for today, because these are the chemicals we're going to use today. So we're not going to use all 20 from yesterday. We're just going to use a few that represent the whole spectrum, or almost the whole spectrum of pH. Yeah, so you can go ahead and write down the numbers and the chemicals. So vinegar had a pH of 3. Aspirin was 4, and if you go in order, it'll help you to see the trend in what we do today. Okay, so I have these ready to go in the lab, and you are going to test these with 2 different indicators. One of them is that natural indicator we talked about, that's the purple extract from red cabbage. That's a natural indicator. The other one is similar to the pH paper. It's a chemical that's been fabricated, or a bunch of chemicals together, and it's called universal indicator. Your goal is you are making the color change chart this time. You're going to figure out the trend. So you're going to have all this data, all these colors from the different chemicals. This time we know the pH. I want you to make one of these. So I have colored pencils in the lab for you to make one of these charts. So once you make the chart, then you become a real scientist, because then you're going to test an unknown. So that's the very last thing. We might not get to it until tomorrow. I'm going to give you an unknown sample, and you have to report back to me the pH, not using pH paper, that'd be too easy. Using your natural indicator and your universal indicator and that color change chart you made, I want you to figure out the pH. I know the pH of the sample. I want you to figure it out using your color change chart.
Okay, I'll go get aspirin.
Of
course, I'll get baking soda. Do we have the indicator? This is tea.
Okay, this is vinegar.
We already did vinegar. Yeah. Never mind. Alright, I need to look. Hey, tap the juice. I'll do the thing.
So this was green. This was so green.
Hold on. It's more reddish.
So what do you
Pinkish.
The shampoo is
Light
right
red.
here.
I say
I
light
think
red.
there's some dissolved in water.
Reddish purple.
No, that's
Light,
green.
that'd be there.
Bright pink.
Is vinegar light?
Alright. You got me some tea.
Look at this pink. Look at this pink.
What's that?
Vinegar with the cabbage.
Pink. Same. That was dark. I put light.
So, did you record your colors that you saw?
Yeah, but
Then what is that?
this is just pink.
So now you haven't recorded that.
Light purple.
This is Lysol. What color does this look
Which one
like?
is that?
That
tea.
looks like,
Hey, this is the same color it was before.
What was
what was
water?
it next to it?
Crystal.
So that's not a surprise.
Hey, I'm betting this is like a dark.
Yeah?
Yeah, because look, like purple, purple. Where we at? This one could be the ransom. Get aspirin.
I have a Google Docs open here. We've been talking about solutions, and believe it or not, freezing and boiling is related to solutions. So I'd like you to think of some anomalies that you've maybe seen in your life related to things freezing or boiling, and then I want you to do a little research and add to the Google Docs why that anomaly takes place. So one that I'm going to show you a video of is about a wood frog. It's actually a type of frog that in the winter, it freezes itself. So it's kind of, yeah, it freezes solid, literally. Frozen solid, its heart stops beating. It's like hibernation, but to the extreme. It's like when people freeze themselves, you know, with the cryoscopic, you know, trying to live for a really long
Like
time.
Austin Powers?
Like cryogenics, yeah, okay? So, the wood frog is a natural animal that does this. It freezes all on its own, but it does it using chemistry, not a freezer. It uses chemistry. So what I want you to do are list some other anomalies related to freezing and boiling, and then I want you to individually research, you know, why is it that it does this? Why is it that this takes place? And as you find your reasoning, put it next to the anomaly. Okay? You know what you're doing?
Yeah.
They're everyday things in life, so start listing them on here. So we've got the wood frog. What else do you know of that changes how things freeze or how things boil? Yeah, what about ice?
It gets hard.
That's not an anomaly.
What's an anomaly?
I don't know what an anomaly is.
An anomaly is something unexpected, abnormal. You don't expect it to happen. You live in Iowa.
Liquid silica.
In the winter, what do we use to mess with the freezing point? Salt. Salt. Okay, that's an anomaly. That salt is used on the roads. Why is it used and why does it work? That's what I want you to look up. Oh, the salt on the road, it's talking about dissolving in water. Huh, it's kind of related to solubility, that it's going to become lower, the freezing point will be lower until no more salt can dissolve. Oh, we've been talking about that solubility.
It's not true.
Okay, so we've got quite a bit of knowledge up there. You should see a trend of how this relates to what we've been discussing. Except for one of them. There's one that doesn't quite fit with the rest.
The tree frog?
No, the tree frog fits. Or what,
Floating tree.
the exploding tree doesn't quite fit. What is it? What's missing from the exploding tree that the other ones have?
All this one is just freezing water. There's no solid.
There's no solute. Exactly. The other ones involve salt as a solute or some other solution. It's not just water. Now, the sap does have the sugar, but the main reason that the tree explodes, it says, is just because water expands when it freezes. And that is not unexpected once you've learned that in chemistry.
So cool though.
It is pretty cool.
Yeah, it is.
Okay?
Who done it?
We could still use a little bit more about antifreeze.
Alright.
When you talked with your table partner, I said I'd give you a minute. What did you come up with? Specifically, what pros and cons do you have about the metric system? Caitlin?
Like, it's easier to use the pieces time.
Okay, so easier and takes less time, like to convert?
Yeah.
So yeah, we just saw that it's really easy to convert, unlike the traditional system. What else? Kyle?
People won't want to switch to it because they're already used to the one we have now.
Okay, so people know the American system, so people would struggle with learning and using the new system, so people would resist.
But then if we keep on teaching it to the younger generation,
People don't use it enough when they're younger.
Well, as right now, they don't.
So not used enough with kids. Galen?
It'd be like easier to convert to somebody in a different country.
Okay, so different countries use it. So communication around the globe.
They say, where's this? And they say 20 kilometers. You're not going to know.
Exactly. Because like I said, we're one of only 3 countries that uses this idea of miles. Now you guys were talking about something. What were you saying about the metric system? It was what? It is good to know, okay? If you go rent a car in another country, you're going to be paying for gasoline or petrol in liters. You're not going to pay for it by the gallon. So it's hard to know how much am I really paying for this unless you know the conversions. So yeah, it is good to know. But it doesn't mean that it's easy to use if you didn't grow up with it. Kyle?
It'll be expensive because then we'd have to change roadside.
Would be a lot to change. All of those mile markers, all of the eighth of a mile markers, would be a lot to change,
And
wouldn't there?
cars too.
Well, most cars do say kilometer in the speedometer.
Yeah, but people would want to change to the big letter. Yeah.
But we have to change the side.
Okay, so cons would be expensive to switch.
Wait, would we have to drive on like the other side of the road?
No.
My bad.
Okay, any other stuff right now that you've thought about?
Makes us smarter.
What makes you smarter by knowing it?
You have to switch your
Okay.
Because then we'd know.
We're not
Yeah,
Nazis.
There's
What?
more pieces. There's more pieces to that, like hexagonal. What?
I think there's less. I mean, when you think of measuring, you've got all of like the fluid ounces, and you've got pints and cups and quarts and gallons, and there's a lot. I think there's actually fewer in the metric system because you have the main sticks that people use all the time.
That's great.
All of the cooking books.
Yeah, cookbooks might have to be reprinted, so that would be expensive. Okay, so fewer units overall, because there's only a few prefixes people use all the time.
Measuring things and tape measures and stuff like that.
Well, a lot of measuring stuff already has both.
I'm 5 foot.
Yeah, so tools would have to change though, because carpentry tools, a lot of those are still the traditional system of inches. So tools would have to change. And we're actually going to watch a video about how much tools would need to change. Mhm. Yep. Any other things you can come up with right now? So, I'm going to show you some videos quick and see if then we can add anything to this list for pros and cons. You guys ever seen American Chopper?
Yes.
Okay, so they're working on a bike here, and there's a problem, bike's not level. So he's measuring it to see the difference between the front and the back, and he has some issues.
This show has a lot of issues.
This show is full of tools.
6 and 7 eighths, right? 7 and a quarter.
Yeah, but see, you can hop curbs with this thing.
What's the difference between 6 and 7 eighths and 7 and a quarter?
So what can we add now for pros and cons?
Lisa,
Peyton?
Still seem like you weigh less.
It would seem like you would weigh less and you could go faster. Now, you still wouldn't actually weigh less, but the number would be smaller, and you wouldn't really be driving faster, but the number would be bigger. Okay?
Already have the food.
Yeah, it is already on food, so we don't really notice it, but food labels are in grams, and this old jug of orange juice that Asarius and I water our plants with, it's actually water though, it says fluid ounces, 128 fluid ounces, 1 gallon, or 3.78 liters. It has all 3 measurements on there, but for the nutrition facts, everything is in grams or milligrams.
Like, I think the way less thing would actually, like, and the go faster thing would actually backfire on them because, like, honestly, as soon as we got used to it, we'd just be like, oh my god, they're fat.
Maybe it would, maybe it would.
And
I think that will always use down.
It would be hard for people to get used to the conversion.
Go!
oh, trucking.
24! Go!
There you go.
19.